Okay, this is lesson 1.3 on arithmetic sequences. We've taken a look at some of the review concepts from the first lesson, and we learned about functions and sequences in the last lesson. Today we're going to look at something called an arithmetic sequence, and it's defined as a sequence in which the difference between each term is always constant. We saw that in the last video, that we had a constant difference. So in this first example, we're just looking at a sequence of numbers, 14, 10, 6, 2, negative 2, negative 6, negative 10. The question is this an arithmetic sequence? Well, it's pretty simple. If you look at the terms in the list, if the difference between each term is the same, if it's constant, then it's true. It's an arithmetic sequence. And in this case, the difference between 14 and 10 is 4, between 10 and 6 is 4, between 6 and 2 is 4, and so on. So because the constant difference exists, it's 4, this is true. It is an arithmetic sequence. Here's another example. The difference between 3 and 5 is 2, between 5 and 8 is 3, between 8 and 12 is 4, between 12 and 17 is 5. Now, there is a pattern there, but because the difference between each term isn't the same, it's not constant, then this is not an arithmetic sequence. So this is false. Pretty simple. So once again, an arithmetic sequence is a sequence in which there is a constant difference between each term. So we looked at a recursive formula or a recursive sequence in the last lesson. It looked like this. This is also the arithmetic sequence, and it's defined as any term n is equal to the previous term, n minus 1, plus d, and d would be that constant difference. And one thing I didn't mention in the last video is there's always a stipulation that n has to be greater than or equal to 2, and that's because the first term is always the u1, and when n is 2, 2 minus 1 is 1. You can't go lower than that. So, if you're given an arithmetic sequence with the first term is 3, and the second term is 4.5, can you, first of all, find the common difference? Well, that's pretty simple. Take the second term, 4.5, and subtract the first term, 3, and you get 1.5. That's the common difference. Now we know it's the common difference because it states that it's an arithmetic sequence, and an arithmetic sequence has to have a common difference. So d equals 1.5, and we found that from the first two terms. Next, can you write the sequence as a recursive function? Well, we have this recursive function right in front of us. All we have to do is plug in the numbers. U of n is equal to u of n minus 1 plus the common difference, 1.5. That's the recursive function. And then the last question, can you find the first 7 terms of the sequence? Of course you can. The first two are given, 3 and 4.5. All you have to do to find the next 5 terms is add 1.5. So 4.5 plus 1.5 is 6, plus 1.5, 7.5, plus 1.5, 9, plus 1.5, 10.5, and the last one is 12. Pretty simple. Now, I'm showing you these examples because what I'm going to ask you to do when this video is finished is practice this on your own in the assignment that I'm going to give you. Alright, now recursive functions are great, except there's one problem. And the problem is, in order to find the next term in the sequence, you have to know the one before it. And that can be a problem if you're looking for the 232nd term, and you're only given the first term. That means you have to find all 232 terms. So a better way to find a sequence, or to find a term in a sequence, is to come up with an explicit form. And the explicit form allows you to come up with a formula that you can find any term anywhere in the sequence without having to know the one previous. So I'm going to show you how the formula comes about, and then I'll give you the formula for the explicit form. So if I'm given the recursive form like this, then I can write out the second term by writing u2 is equal to u to the 2 minus 1. 2 minus 1 is 1 plus d. That's the second term of a recursive or arithmetic sequence. Okay, to find the third term, you would take 3. 3 minus 1 is 2 plus d. All I'm doing is putting this 3 into this formula. 3 minus 2 is, or excuse me, 3 minus 1 is 2. Now, the third term is u2 plus d, but we know that u2 is this. So I'm going to put this in place of u2, and I get u1 plus d for the u2 plus the d. And that gives me u1 plus 2d. I try to find the fourth term. The fourth term is the one previous to it, so u to the 4 minus 1, or 3 plus d. But we know that u3 is this right here. So I'm going to put u1 plus 2d plus this extra d, which gives me u1 plus 3d. Now, if you see the pattern, that's great, but I'm just going to give it to you. Here's what's happening. Every term in this sequence can be found by taking the first term, u1, 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 and adding some multiple of d. And it turns out that for the second term, it's 1d. For the third term, it's 2d. For the fourth term, it's 3d. And what you should notice is this coefficient in front of the d is always 1 less than the term number. So that gives us a general formula that we can use without having to go through the whole recursive step. And here it is. You can find any term in a sequence by knowing the first term and adding n minus 1 d's to it. But what the heck does that look like? So here we go. Find the nth term of an arithmetic sequence with the first term of -5 and a common difference of 3. Well, this is the explicit form for an arithmetic sequence, which we just figured out. To find the nth term, to find u of n, you're going to start with the first term, which is given to us as -5, plus n minus 1 times the common difference, which is 3. That's it. Now this is an explicit formula for the nth term, but it can be simplified. So we're going to distribute. We're going to get -5 plus 3 times n is 3n. 3 times -1 is -3. So our formula for finding the nth term of an arithmetic sequence is 3n minus 8. Alright, one more example. What's the 45th term of the arithmetic sequence if the first 3 terms are 5, 9, and 13? Now, here's where the explicit formula comes into play. If I want to find the 45th term without an explicit form, I'd have to find the 44th, the 43rd, the 42nd, and all the way down to the first term. But because we now have an explicit formula, we can use the fact that we know the first term is 5 from the sequence. We can quickly look at this sequence and see that to get from 5 to 9 and 9 to 13, the common difference is 4. So the common difference is 4. Now we can come up with an explicit form for this sequence, which is UN equals, replace U1 with 5, plus n minus 1 times the common difference, which is 4. Now, just like the last one, we can simplify this if we want to, but we know we're just trying to find the 45th term. So we're going to find the 45th term. That means n equals 45. So I'm going to take n and plug it into our formula. 45 in place of n. 45 minus 1 is 44. (44) times 4 is 16, carry the 176. Plus 5, so the 45th term of this sequence is 5 plus 176, which is 181. Which was a lot faster than trying to find the first, second, third, fourth, fifth, all the way up to the 45th term using a recursive sequence. Okay, that's it for this lesson. I'm going to stop the video and let you do the next assignment.